Okay, we're going to look at a trigonometry question from the Prelim paper 2, and it says, without using a calculator, question 5.2, determine the value of the following expression. Cos of 350 sine of 140 minus the cos of 440 times the cos of 40. Well, I see right away this cosine thing on my formula sheet. The sine of the difference of two angles, well, there's sine times cosine, sine times cosine. This formula is probably a place where I want to go. Now, if I see two coses, I can change one of the coses into a sine by going sine of 90, cosine of sine of 90 minus that angle, and that will give it to me. So anyways, the first thing you do is you find the reference angle of 350 degrees. It's 10 degrees away from 360. So this is the same as the cosine of 10 degrees. And that's it. That's your first mark, just doing that. It's the cosine of 10 degrees. Now, this is 40 degrees from 180. The reference angle is 40, and the sine is positive, just like the cosine is positive in the fourth quadrant here. On the next one, this is 80 degrees more than 360, but cosine's positive at 80 degrees. So this cos of 440 is the same as the cos of 80, 80 degrees past 360. And there's your cos 40. Well, now I was saying before, the cos of 80 is exactly the same as the sine of 90 minus 80, the sine of 10. And now we've got it. We've got the 10 and the 40, the 10 and the 40. And the commutative principle means that I can switch this and make it sine 40 cos 10 and cos 40 sine 10. Well, now we have the answer. The sine of those two angles subtracted is your answer. And the sine of 40 minus 10 is the sine of 30. And they said without a calculator, so I guess I better have my special triangle that shows that I know that the sine of 30 degrees opposite over hypotenuse is 1 over 2. Okay, that's just how it works. All you do is you get a question like this, you reduce everything, so you take a look at it, and then look at what the possibilities are. Sometimes there's more than one way to do it. But this one, it falls out sine, cosine. This combination of sine, cosine, cosine, sine was the way to go. Okay.